In question number 4 on the next page, we're going to try to piece together some of the things that we were dealing with the equations and their connections to all the patterns so that we can really start to make some sense of how these problems are going to shake out. The clues that were given in question number 4 are going to give us a hint about what kind of pattern to think about, and then we're going to try to do two things. First, we're going to try to connect the missing numbers in the sequence so that we can predict what the pattern was, and then we're going to use those pattern numbers to help us write the equation. So I'll start with number 4, letter A, and let's think about pattern finding. They're telling us in letter A that this is a geometric sequence, which tells me that I have two options. It's either going to be a multiplying or a dividing sequence. That's all I know right now, but I know that much because it tells me that it's geometric. Now, as I think about what that could mean, I do want to look at the numbers and ask myself logically, okay, well, how would I get from a 64 to a 1/4? In case 1/4 is not helpful, you can always convert it to a decimal, that's 0.25. But I can clearly tell that I'm going to have to be getting smaller and smaller and smaller and smaller as I go through the sequence. So that's tipping me off that I'm probably going to be thinking about a dividing pattern. Dividing is what makes things get smaller. So I'm going to focus on dividing. And I don't really know what to divide by yet, so one strategy you could try is to just kind of guess a number and see if it works. For example, what if I tried dividing by 2? I'm just going to try it and see if it works. And if it doesn't work, then I'll just try something else. So let's say I tried dividing by 2. I'm going to write that really lightly because I'm not committed to it. I just want to see if it'll work. 64 divided by 2 would be 32. 32 divided by 2 would be 16. 16 divided by 2 would be 8. 8 divided by 2 would be 4. Nope, that's not going to work because 4 is too big. That's definitely not going to be the 0.25 that I needed. So dividing by 2 is not going to work. I'm going to erase all that. I'm going to have to try something else. I'll try another number. I could try dividing by 3. Ooh, that's not going to work out too nicely. 64 isn't really easily divisible by 3. So maybe I'll try dividing by 4. 64 divided by 4 is 16, divided by 4 is 4, divided by 4 is 1, divided by 4 is 1/4. Hey, 1/4 is 0.25. Hey, that works. So I had to guess. I kind of wasted a little bit of time on one possibility that didn't work, but here I am. Now I know a possibility that works. I know that my pattern is dividing by 4, so I know for sure that these missing numbers are 16 and 4 and 1, and now I can be absolutely certain that I know the pattern. The pattern is for sure dividing by 4. Now, because I know the pattern is dividing by 4, that also tips me off about how to go backwards and get the initial value. Because if divide by 4, divide by 4, divide by 4, divide by 4 is how I can go forwards through the sequence, I can go backwards and do the opposite. The opposite of dividing by 4 is multiplying by 4. So picture it. 1 times 4 is 4. 4 times 4 is 16. 16 times 4 is 64. So 64 times 4 must be 256. That tells me what I had to have going backwards. And I can always check if I wanted to. I could check that 256 divided by 4, yep, that makes my original pattern work. It would have been 64. I'm good to go. So now that I have the important information I needed the initial value, and I needed the dividing number, or the multiplier we're calling it. Let's see if now we can write an equation. If it helps, you can always look back at your notes about what a geometric equation looks like. So we can copy that structure if we want to keep it near us. We need T of n equals the initial value, which is 256, times, because it's a multiplier, now I have to think for a second. It's dividing. How do I write that? Oh yeah, wait, I've seen that on previous pages. I just want to remember. We've talked about it. Oh, there it is. Bottom of page 3 there. If you are dividing by something, use a fraction, 1 over whatever you're dividing by. So that just tips me off. I'll write this multiplier as a fraction. I was dividing by 4. 1 over 4 to the power of n. Notice how n is going to be a power, little exponent, because that's how it always looks with a geometric equation. Now that you've seen an example of the type of thinking involved with a geometric pattern, try the other geometric pattern here, which is question letter C. If you can try question letter C, that'll kind of link the ideas together. That way you have some consistency and you'll have an equation that looks very similar to the one we did in this example. After you figure out what's going on in this example, then in the next video, we'll talk about an arithmetic example for parts B and D. But let's break it up a little bit so that way you can kind of follow a geometric with a geometric. Then we'll lump together the arithmetic with the other arithmetic.